Okay, so this is 10A, which is types of reactions. These are just basic types of reactions, okay? This is not when we've done neutralization for acids and bases yet. This is not when we've talked redox yet, and this is not when we've talked the organic or nuclear reactions yet. So these are the 5 basic types of reaction. The first one is called synthesis. Synthesis, you'll know, is to make, right? The word synthesis means to make. So synthesis, the trick to tell that it's synthesis is that it has one product. So it's going to have a generic look to it, like A plus B forms AB. There's going to be no plus sign over here on the product side. It's only going to make one thing. So you might see something like this, H2 plus O2. I'm going to balance it. Gives me H2O. Okay, this is the synthesis of water, and you'll notice there's only one product, but there's multiple reactants. The opposite of that is decomposition. Decomposition, I don't know if I spelled that right, it's early, is the opposite of synthesis, okay? So you'll know that it's decomposition because there's only one reactant, and it's going to break apart into products. So it'll break apart into more than one product. It could be 3, it could even be 4. So if we look at the decomposition of hydrogen peroxide, for example, I'm going to need one of those into water and oxygen gas, okay? That's decomposition. You'll notice there's only one reactant versus synthesis that has only one product, okay? Ooh, what did I do there? I don't know. Okay. The next one that we need to talk about is single replacement. Single replacement, you're going to look at table J for, and I'll talk about that a little bit more in our next video, 10B. But single replacement has an element and a compound, and what happens is the single element switches with one of the elements in the compound, leaving a different element alone and forming a new compound. And I talk about this like you go to the prom with your date, okay, and then somebody cooler comes along, cooler as predicted by table J, and comes along and tries to take your date. And if they are cooler than you, then your date is fickle, they will leave and leave you out in the cold. So an example of this would be copper plus silver nitrate forming silver and copper nitrate. Okay, there's your element. It's replacing that part of the compound, leaving a different element alone. So that's single replacement. And then obviously we were going to have a double replacement. That's why we have a single and a double. So double replacement, you go to the prom with your date, and your friend goes to the prom with her date, and then you look at her date, and she looks at your date, and you switch. Okay, so your negative ones that are written second, switch. This will only happen as predicted by table F, and if it produces a insoluble salt or water. So a real example of this would be, I don't really want to use nitrates, potassium chloride and silver nitrate forming potassium nitrate and silver chloride. And what you see here is that the silver chloride, according to table F, is insoluble, and that's what you'll see when this reaction happens. Everything's an aqueous compound, an aqueous substance except for that silver chloride, and that's what's going to make it look cloudy. Okay, and that's what you'll see, and so you know that the reaction happened. The last one that we need to talk about is combustion. Combustion is a very specific type of reaction. You're going to start with something with carbon and hydrogen. It could have oxygen, but it's got to have at least carbon and hydrogen. And you're going to burn it in oxygen, and it's going to form carbon dioxide and water. This is so specific that this part of combustion is always the same, okay? You must end in those two products, no other products. So it's not like if you have CO2 and something else that it's combustion. No, it has to be CO2 and H2O. And you have to have oxygen as part of the reactants. And that's how you'll know that it's combustion.